Let me guess, is there a midterm today? Turn that down a bit. Okay, let's, well, this is not going. Let's see. Let's send this to the display. That's strange. There we go. Okay, success. Okay, so today we're going to talk about milestone 2. So milestone 2 is all about visualization. You're going to interactively visualize a map. It's more open-ended than milestone 1, so the specification is loose. You fill in some of the details. What are we teaching you? We're teaching you the basics of graphics. We've already taught you important data structures and how you can use them quickly. And you've learned how to use OpenStreetMap data. So you're going to build on all those things. For the best solutions, you'll also come up with some of your own ideas. So it's a bit different than most labs. Labs apply what you go over in lecture, and you'll be doing that as well. You will be applying what we tell you about. But basically, to get the best solution, you're going to go beyond what we tell you, do some independent investigation as well. Okay, so that means whenever you have like more loose specifications, you can kind of go beyond the basics of what we teach you. That's going to kind of stretch you a little bit, right? Could be stressful because it's not quite as clear when are you done, which is typical of projects. Okay, so how can you manage that well? Well, start early. So my advice is start on milestone 2 over reading week, because as Professor Chong said, you're going to have a bunch of things after reading week, WD1, then milestone 2, then a presentation. So even though the due date for milestone 2 is quite a ways away still, it's not a good idea to kind of let yourself get really close to that, because it's more open-ended and there's a lot of stuff coming. Get something working. So this is not a situation where you can make it, there's no perfection here, right? Like this will never be done. You could spend a long, long time making better and better visualization software. You want to get something working because most projects, including this one, you eventually run out of time. So you may have a grand vision of everything you want done, but you have to accept you may not get all that done. If you get something working, then if you run out of time, you always have you say, I can hand this in. It's a lower stress way to run a project. It's a safer way to run a project, not just in school, this is how I'd run project in industry too, right? If I run out of time, how much do I have working? Because you usually do run out of time. Once you get something working, improve it, but you're generally not going to be, well, maybe there'll be somebody who considers themselves perfect on everything, but normally there's no end point, right? You're not perfect. You just get it to a point where you go, yeah, it's pretty good. I'm pretty happy with it. I have other things to do. You move on. So remember this slide that I showed in the very first lecture? You basically want to be somewhere in here, right? You learn the most when you're feeling, I'm a little bit out of my comfort zone. I'm doing things that I haven't done before. I'm not kind of on autopilot. You don't want to be down here, and I don't think you will be for milestone 2, where you say, this is so easy, I could do it in my sleep. But you also don't want to try to be perfect or try to do all the most difficult things you can think of and make that your whole plan with no backup strategy, because now you're probably biting off more than you want to, and it's going to be stressful. So try to keep these ideas in mind. Okay, so what are you doing for milestone 2? Well, so we told you that we've got these 2 API layers to talk to the OpenStreetMap data. We have what we call the Streets Database API, or the higher level, layer 2 API, where we have street segments, intersections, features like parks, and so on, points of interest. You basically have to visualize all of that. Okay, you've walked through that data in milestone 1. Now you're going to figure out how to draw it, let people interact with it, make it intuitive, make it responsive. Okay. And then we have the lower level OSM database API, which is all the data that's in OpenStreetMap, this huge open source database of the world. It is less structured, but there is more of it. So you can optionally go into that data. And you did work with it some in milestone2, so you're familiar with some of its basic conventions. You can extract extra data from that, visualize more on your map. It'll look nicer. Okay, so for example, subway stations. Our higher level, more organized API has not given you subway lines or subway stations, anything like that. But it's in the OSM data. And that particular one, if you go to the OSM quick start guide that we wrote for you, we actually give you a tutorial on how to get some of the subway data out. Okay, so we actually get you started on that. But that's not the only thing in OpenStreetMap. It's got bike routes, it's got bus routes, it's got trains, it's got all sorts of information. It's got information on the heights of buildings, etc. So you can gather a lot of interesting things out of it and layer them on top of your map. Okay, so if you're interested in getting more data, start by reading that OpenStreetMap quick start guide that we wrote, and then you'd plan on some experimentation. This is low-level data. You have to kind of write some code and to print out the data that you're interested in and figure out, okay, how do I make sense of this? Okay, so milestone2 has got some basic requirements. And I kind of just mentioned these. You have to visualize everything in that upper level API. Well, more specifically, you have to be able to see the streets, all the features, so buildings, parks, lakes, etc., and the points of interest. So, you know, Tim Hortons, Starbucks, etc. You also have to be able to interact with the user. So if a person clicks on an intersection, you have to show some information about that intersection, which means you have to figure out when a person clicks the mouse, well, what are they clicking on? You also have to be able to find intersections by name. So the specification is in the document, but basically if they enter the name of two streets, you figure out the intersection where they intersect and you highlight it and give some information. Some of these, you might, if you remember your milestone1 functions, there's some functions that you've written that could be pretty helpful in this, and that's on purpose, all right? So you're not gonna use everything you wrote for milestone1. Some of that was just a learning exercise on how to build good data structures and how to get used to our data. But some of the functions you wrote, you're gonna see, if you remember them, you're gonna go, hey, this is a really useful, helpful function now. You have to be able to, we're not gonna just test you on Toronto. So I'm gonna show you Toronto usually when I'm showing an example, but we have about 20 city maps that we've downloaded. They are around the world. We chose cities that kind of have look interesting or use different languages, etc. So you have to be able to load any of those. The ece297 exercise will actually automatically load up a whole bunch of them, so you can just click through and check that you work with them. There are a few others it doesn't run, but you can see them in our public map directory and try them out. You can't recompile, so what that means is you're going to eventually demo this program to your TA after it's due, and you can't go in and start, if the TA says, okay, I want you to open up Tokyo, show me what Tokyo looks like, you can't say, okay, let me just hack the code here, right? I'll hack the code and then I'll recompile and we'll open Tokyo. We don't care how you open Tokyo, except you're not allowed to go change your code, because an end user of your program, you know, wouldn't be able to do that. Your graphics should be fast and interactive. Okay, so how fast? That's part of what you're figuring out in written document 1. What does that mean? But we don't, doesn't have to be perfectly smooth. Most teams won't achieve that, but you're trying to make it not so laggy that it's annoying to the user. So you try to keep the speed up. At the same time, well, you're also gonna have to use level of detail to help meet that goal. So what do I mean by that? If you read the specification of milestone2, we're asking you to visualize a lot of data, like all these points of interest, all the parks, all the streams, all the streets. If you draw all that all the time, your map will be slow, and you're probably also going to overwhelm the user. It's probably going to look very cluttered. So you need to come up with a level of detail strategy. People have to be able to get that detail somehow, but that doesn't mean you should be showing it to them all the time. So that's part of your challenge. Don't hard code things, okay? So I guess I already mentioned this. ece297 exercise is helpful to you because it'll open up a bunch of maps, and you can use that to test your program. We'll run valgrind. Actually, ece297 exercise will run valgrind automatically on your program. Make sure you don't have any memory problems. But in grading, the TA is now actually going to run your main program, mapper. So you are going to have a little bit of code in main/source, main.cpp. We give you a little skeleton file there. It's not going to be a lot of code, but enough code to basically get your program going, call your draw map function, so that you can actually demo that program to your TA. But most of your code, just like in milestone1, is actually going to be in that library, libstreetmap source. And the reason you put it in there is so that our unit tests can call it. You can use it to check all of these maps, and your main program can call it. There's only one function. If you look at well, I think I've got this on the next, I've got it in a couple of slides of what you do. But basically, you've got a lot of freedom of how you write that code, but basically most of it should be in libstreetmap source. Any questions on that? So I'm going through a lot of stuff pretty quickly, but if you go through the handout, it details this. The handout and the rubric detail this much more. Okay, so this is kind of a quick overview of what's in them. Okay, grading. So this is worth 16% of your course mark. So go see the rubric for details. Your TA is going to fill this out after you demonstrate your map to him or her. So just like in milestone 1, part of your mark is on how you did things, not just what you achieved. So code style, project management, did you use Git well? Basically, it's exactly the same rubric as milestone 1 for that. So what your TA tells you did well or poorly in milestone 1, on that front, pay attention, because he or she's going to grade you on it again. 5 marks come from basic features. Okay, so basic features is, can you do all the things I mentioned? You know, can I click on an intersection and it's highlighted? Did you draw all the streets? Did you draw them correctly? When I type in the names of 2 streets or part of the names of 2 streets, can you go find the intersection where they intersect? Okay, so did you do all of that? How responsive and how aesthetically pleasing is your map? So does it look nice? Is it very laggy, or is it pretty responsive? And one of the challenges in that you're going to find is to display street names well. So we don't want you to just draw the streets. We also want to be able to figure out, well, their names. Which street is which? That's harder than it sounds, because streets are curved. They cross each other. If you draw all the street names all the time, you just have text all over everything else, so it looks really messy. So it actually is relatively challenging to algorithmically, for any city, draw the street names so that they kind of line up well, and you draw kind of an appropriate number, right? You don't overwhelm people when you're zoomed out, but as you go, there's some method by which as you zoom in or turn on features, you can figure out the name of the street. So that's one of your challenges. And then another 5 marks are coming from what we call extra features. So extra features are, we're not telling you exactly what to do. So do some more things beyond these basic requirements. Here's some ideas, right? So show more data. I already talked about that from OpenStreetMap. We're asking you to be able to click on an intersection and you highlight it and you show information about it, but you could do more. So maybe you make that work for streets or parks, etc. You could get data from the web. And to help you do this, we've written a quick start guide on libcurl. Libcurl is actually libc URL. It's basically a library that allows you to go out to the web and get data from C. So you can read that, and it gives you some pointers of what are sites that might have interesting data that you want to download at runtime and basically show. Maybe you want to show the current weather. Maybe you want to show the current traffic. Some of those things are easier, some of those things are harder. You can also make your UI more attractive, more full-featured. So I'm going to talk about this in the rest of the lecture, but basically we've made a relatively easy-to-use graphics library for you, but you can go underneath it if you want to get some additional features from what's called GTK. GTK is the library that we're building on top of, or one of the libraries we're building on top of. We have a quick start guide for that too. So you don't have to do this, but you could incorporate more fancy dialog boxes, search bars, etc., that might make your UI look nicer and be easier to use if you go into that more detailed library. But it'll take some investigation and some work. And you may have your own ideas. You know, what do you think would be a cool feature to implement? If you go to this rubric, It basically gives a bunch of ideas for possible extra features, as well as how hard we feel they are, and therefore how many marks they would be worth. And you'd want to pick extra features that add up to at least 5, so that you have a chance to get full marks if you do them well. But you can also come up with your own ideas, and if you want feedback on, does this sound good, does this sound easy, does it sound hard, ask your TA. Okay, so I think I'm going to hold off on the demo of this until the end of class. Any questions on that so far? I think most of you remember, like I've shown this, the teaching team solution before. How many people remember what this looks like? How many people don't remember what it looks like and want me to show it right now? It's a tie. So what do you think? Should I demo this right now? Or okay, so if you want me to make it concrete, that might be good then, so I'll do that. And I'm going to switch computers because this one is inexplicably not connecting to the UG machines right now. Okay, so let's try this. Okay, so I'm running the teaching team's reference solution. We haven't focused extensively on beautifying this, so it wouldn't be probably the greatest, it's not terrible, but it's probably not the best map. So this is Toronto, so you can see the highways, you can see some of the parks and so on, and I can do things like zoom in. Okay, so as I zoom in, you'll see that at some point we start showing more detail. Okay, so we just showed more streets, and we started showing houses and so on. I can zoom in further and further. And eventually we start showing names. And maybe those names are annoying, so I can turn them off. Oh, actually, now I just turned on street names. And I have these little fonts, and these yellow dots are points of interest. So they're hard to read, but for example, this one says the UPS store. All right, and we can turn them off, because maybe you find it too cluttered. We can turn them on. We can turn some detail off. We can turn some detail on. Let's turn that back on. So what do you think of my street naming? I told you street naming was kind of one of the challenges here. So here's a street. I put a little red dot on it, and I put a name that's really small, so it's actually really hard to read. Yeah, I still have trouble reading that. That road starts with M, okay? But I can't read the whole thing. What do you think of my street naming? And I named this, I put a label on this street, and I put a label on this street, and that's about it. 2 streets labeled with red dots, small font. What do you think? Am I getting full marks? No, getting the thumbs down. Okay, so we didn't put much effort in our street labeling. So you should do better than this. Like, our aesthetics on street labeling are pretty terrible, actually. The label is, I don't know, kind of clunky to put a big red dot, and then we use too small a font, and then we're probably not labeling enough streets. If I keep zooming in, like, so if my TA says you're not labeling enough streets, I can say, oh, let's zoom in, we'll label them later. But we never do, right? So there's some streets on here you're just never gonna figure out what they're called. So that's not great. Okay, I can hit this zoom fit button. I go way back out. I've turned on all sorts of detail right now. I can turn that off. Okay, that looks a bit better. So I have some controls over how much detail to show. I can turn, do I want to see like natural features like parks and rivers? I can turn that on or off. So we have some interaction here. And actually we didn't actually bother doing the selected intersection, so when I click, it actually invokes an algorithm from milestone2. So I also missed some basic features. So our reference solution is primarily intended for us to be able to generate tests and to test our algorithms. We did some of the visualization, we didn't do everything you guys should do. Okay, let's see, I told you that you have to be able to open another map somehow, so that was Toronto. I can actually give the name of, let's see, well, my mapper actually will give me help. Okay, so mapper, help. So it basically can take a map name. And let's do New York. Okay, so we can give it the name of a map and open a new one. This is fine, okay? We said no recompile. Hey, I restarted the program, but didn't recompile it, so that's okay. Maybe it'd be even more user-friendly if I had some button that allowed me to change the map, but I don't. And let's see, one other thing we have an extra feature of show the subways, okay? So we did go into OSM and figure out the subway lines so we can see those. And Manhattan has lots and lots of buildings, as you can see. And New York has more subway lines than Toronto, so they've done a better job building it. Okay, so that gives you hopefully some idea of what are you trying to do. But you should do all the features rather than not doing them all like we did. Any questions on that demo? Okay, because if not, I'm going to switch back to the other computer. Okay, and you can see, like, if you're watching closely, you can see the map was reasonably responsive, but it's not like 60 frames a second. That's fairly typical of what people will achieve. There are a few teams that actually will get hit like 60 frames per second on lots of maps, but it's not that easy. So your TA is looking for reasonably responsive. Doesn't have to be perfectly smooth, but if you achieve that, great. Okay, so the tutorial this week is a walkthrough of how to get started on milestone2. So I strongly suggest you go to that. If you already missed it, watch a video, because it can be a little overwhelming. How do I get going with this, all these libraries and this graphics and so on? So we kind of walk through how to get started and a bunch of common issues you might have. Okay, so we said that you have to do all these basic items, and then you have to come up with some extra features. So here's a potential extra feature. I could change the color scheme of my map. Okay, so I'm going to make a pinkify button, and every time I click it, the map gets more pink. So what do you think of my extra feature? It's fantastic, like 5 out of 5. Okay, so I see people are skeptical. So yeah, in extra features, difficulty matters. So you can make more than one, and probably, actually, none of them are considered difficult enough to merit 5 marks, so you should do more than one extra feature. This would be a very simple extra feature, right? This one might be worth, like less than 0.5. Like easy features we consider worth 0.5. This one is probably less than that because it's very easy. It's just a pink background. And it's pretty debatable that this is highly useful as well. Okay, so a more difficult one, worth more marks. Okay, how does this relate to WD1? So WD1 is all about making a proposal and doing background research that relates to geographic information systems and how they display information. This is a good thing to do in any project, right? So when I'm starting a project, or my grad students are starting projects, the first thing we want to do is survey the landscape. So we want to do background research, and 2 of the challenges that we've identified in WD1 and also show up in the milestone1 or milestone2 rubric are how are you going to make your GIS responsive so it feels interactive? And how are you going to make it easy to use, but it can still show lots of detail? Because we're asking you to be able to show all the detail in these cities. So you could just come up with your own ideas for that. But before you do that, it's a good idea to see, well, what do other people know? Okay? Or at least at the same time as you're coming up with your ideas, you look at what other people know. So this is not completely new. No one's ever thought of making a user interface. What makes them intuitive? What makes them feel responsive? Okay, and I've actually seen people skip this even in like graduate degrees, right? They'll do their graduate research for 2 years or 4 years, and towards the end of it, they realize they have to write a thesis, and they go do a bunch of more background research so that they can write a chapter summarizing the background. It's dangerous to do that at the end, because sometimes after spending 2 years working on something, they do the background research and realize, oh, someone else said that this was actually not a really good way to do this. There's a better way. Now they have a writing challenge of how do they write down that this is a known thing, that the rest of what I did is probably not that smart. So do the background research at the start. You may disagree with some of it, that's fine, but you're aware of it all. Okay, so you survey the landscape, now you make a plan. What are you going to do? And in particular, how are you going to use these ideas from the background research, and how might you be different from them? And then how are you going to measure success? So what is your testing plan? And the background research might give you some ideas here, so that you don't just say, I think we did well. Can you make it more concrete than that? Okay, so let's take a couple of minutes, and I want you to talk at your table, or if you're by yourself, go join another table. Do you have ideas of how you would check, is a user interface, we're making a visualization user interface here, how will we make that check if it's usable, and how will we check if it's responsive? So part of your WD1 assignment is to clarify what do these terms mean, but why don't you come up with some ideas of what you think they mean, how you think you would test them, right? So it's implicit in what you think they mean, how you would test them, but let's focus on the testing. How are you going to check this? Okay, so let's take a couple of minutes and discuss.
So I think for usability, one of the things we could measure is if there's a lot of information on the screen. Oh, what's the feedback? So if there's a lot of information on the screen, if you're trying to click on something that's pretty detailed, but it's maybe not being as accurate as you'd like it when you're clicking, maybe that's one thing you could account for in your usability is how accurate can you be with your clicks?
Yeah. So accuracy of input. So can you easily select?
Exactly. And then for responsiveness, one thing we came up was, what are people okay with waiting for when loading stuff? So if you're searching for a POI, how long are you okay to load versus when you're waiting for a new map to load in?
Right, so responsiveness, so part of it, identify a key thing. Responsiveness is a human thing, because if you feel responsive enough, it's going to depend on how long are people willing to wait. So it's something we want to figure out in background research. So we help with WD1. So those are good thoughts. Let's go to E06.
Hi. First of all, That's a nice haircut. Number two, for usability, we were talking about more of like reducing the ambiguity of what any button does. So if you have to make it clear that every POI is like a subway station or a street or like a Tim Hortons, for example. As for responsiveness, we were focusing more on like the speed at which a user can, for example, move around the screen. Yeah. 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 I would say measure the time between the user input and the redraw for that specifically.
So measure the redraw speed or time from input to response. How do you measure it? Do you measure with a stopwatch? What do you do?
Today in the tutorial, we were looking at the chrono library.
Yeah, so that's a good answer. So there are timers that you can do. So in C++'s library called Chrono, I'm going to show you some sample code on the next slide that you can just use. So you can use a stopwatch if things take a long time, but it's hard to reproduce and it's certainly not accurate if you're trying to get down to well under a second response times. Some things you probably want. So better is to actually write code that can actually measure the speed. It's much more complicated. So yeah, good answers. So let's go to, did you have a comment, Lenny? So I'm going to go to B06.
All right, so another benefit for usability could be having a variety of features because more features is always great for usability.
So you say more features will make it more usable.
A wider variety of features.
Okay, so so it makes sense. I mean, a program just can't do what you want, it can be annoying. On the other hand, can you ever have too many features? Or can that ever be an impediment to usability?
Yeah, for sure. That's why the variety. That's why the point right before making sure that ambiguity is reduced and making sure every feature has its own like job is important, but also having a variety is also. So there's a balance you have to strike there.
Yeah, yeah. See, the classic trade-off is hard to evaluate, right? Steve Jobs basically fought very hard. It's one of the things he's famous for is fighting against extraneous features because he wants simplicity. And there are lots of studies that you can find to show most people don't know most of the features in the programs they use. So adding more of those features might be a waste of time, might also just be annoying, right? That I just can't figure out how to do anything. But at the same time, if a program just can't do what you need, then that also is really annoying. So any idea
Or maybe you could like have people try it out and see what they think about it.
Yeah, so you have people try it. Definitely a very good way to do it. So who should try it? Your team? Somebody else? What do you think?
Start with the team and then eventually like test it out with multiple other people that are not really involved in the project but have interest in it somehow.
Yeah, so I think that's a very good idea. So not just your team, although you will have your team try it because you guys are the experts in what you're trying to do. So you're a model for an expert user. Do you like it? Also, you have a very fast feedback loop, right? Do I like it? If I don't, I'll change the code. But you don't want to just have the team do it because you're a model of an expert user, like actually a super expert user who knows exactly what you're intending to do and so on. A novice user who's like a friend from first year or 295 or something provides a different perspective of I actually don't understand this interface. How quickly can I discover it? And their feedback can be very different than that of an expert. So it's good to do both. So that's good. And what would you, maybe I'll go back to you again. So now you got your user base, you get to do things. Well, how would you get their feedback? Ask them questions, what would you do?
So you could do it in a few ways. One way is to like be with them while they're trying it out so they can tell you directly. If you're remote, you could have them email it to you. Just use the same method of communication you use to give them access to the like software to have them give you feedback.
Yeah, okay, so you can watch them, ask for feedback. Both good ideas. Anything else you might do? So for testing, we got down to, or testing responsiveness, we got down to these time things. You have to figure out what's good and what's bad, but you could write timers. And getting feedback from both expert and novice users is good. Watching how they do things is good. Do you think you can get anything that's, you need that, right? But can you get anything that's like quantitative for at least part of this, to give some more guidance beyond just asking, did you like it? What did you like? What didn't you like? So I can think of something. So maybe you guys can think of one or two things there too. So can anybody think of something concrete you can measure, not just ask them, to help assess its usability? So let's go to C07.
Could you take measurements while they're performing the actions in the application? Maybe you've created a set of guidelines you want them to test a certain number of features, and then you take measurements along the way to see how they compare against maybe other people who did it, and then you could do the results together and see what the average time was for people to do specific actions.
Okay, so I totally agree with that. I think it's like, give them a task list, right? So I'm going to repeat this back to you, see if we got it all right. So they give them a task list, and then basically time how long it takes. Is that right? And yeah, that I think is a very good idea. So time that task list. The reason that's good is, well, again, it's concrete, and you can measure, relatively small improvements. You can measure big improvements, but you can even measure as in 10% better. Having a mix of expert and novice users is useful because the novice users tell you, I don't know what's going on. I'm going to be slower, but I can't even figure out how to do this like ever, right? Or it's just like half an hour later, the person's just still sitting there clicking at random, right? It's trying to find the door. And your expert users tell you, once you really know the interface well, it's maybe your development team, how fast can you get stuff done? So when it was at Altera, we would do both kinds of usability testing. Right? We would have expert users and more novice users. We would time how long it took them to do some tasks. We'd actually have them go into a room and work with the software, like Portis, and videotape it. So it could be shown to the developers so they could get a sense of what they get confused by and so on. But you had these concrete measurements of how long does it take to do things. And it can be quite different. Obviously, experts are faster, but what experts want can even be different. They like shortcut keys and so on. So it's nice for that to exist for them, but the novice users don't want that, or they don't use that. Like they want to be able to discover stuff because they just don't know how to do it. So you get quite different feedback. So yeah, so I think these are great ideas, and hopefully some of these ideas help you in both WD1 and milestone 2. Okay, so one of the things we talked about is that if we should time the program. It's a useful thing to do. Stopwatch some Windows machines, or maybe some Linux machines, or maybe a printer, but it's not going to work on all of those, unless you go and write code differently for all of them, because actually the low-level hardware is different. That's a huge waste of time to have all sorts of people writing the same code, many times. And then the last thing is when you're an ece241, you are running right on the hardware. There's no operating system, there's no protection, right? If you do something that will melt that chip, you'll melt that chip, okay? But we don't allow that in computer systems where you have multiple programs running and potentially multiple users. The operating system protects them from each other, and that's why you get sig faults. You try to access some memory that you don't know, and the operating system kills you. You can't access the graphics hardware directly. It's protected by the operating system. So if you try to do that, your program will just be killed. So what do we do instead? So we write to an application programming interface. It's higher level, so it's easier for us to write our functions. That application programming interface, basically, you talk to one side of it, like I want you to do things. The other side of it talks to what's called the device driver. The device driver is low-level code that someone wrote that does know how to talk to the hardware. That code is allowed to access the hardware. By writing your code to this API, it means that you will now run on any hardware that that API supports. Now, that means that people who wrote that API have to go write a bunch of device drivers, but that's okay, right? They do that once and then all the programs can use it. And device drivers are special. They're written in a special way where the operating system trusts them. They're allowed to access the hardware, whereas your regular program isn't. So it will work, and now you can actually make your program run on a bunch of different platforms with much less work. Okay, so you've got your program. It's actually Mapper. You're going to talk to a graphics library that myself and some of the TAs wrote called ece2, ece2. It's a relatively simple to use graphics package so that you can be pretty productive, especially for a visualization project like this, where you're mostly concerned about drawing complicated data. So everyone's going to use that level. Now, ece2 is itself layered on top of things. This is very common for graphics APIs. There's kind of layers of abstraction. So ece2 is layered on top of a full-featured graphics toolkit, right? So that means buttons and user interface elements called GTK. Most of the programs that you are running in the Linux machines and the UG machines are actually written in GTK or talking to GTK. If you want to, so we have a quick start guide for GTK. So you can read that. It tells you how to go underneath ece2 if you want to get it some extra user interface features. If you just got to have this fancy button or this fancy file selector or something, you can do that, but it'll be some more work. And then GTK itself, and ece2 are talking to a couple of other libraries, X11 and Cairo, to do the low-level drawing of polygons and lines and so on. Okay, so this is how it works, but you don't really need to know all these details. You're going to talk to ece2 for sure, and you might choose to directly talk to some GTK functions. You won't have to do anything below that. Okay, and your program will now run on all these different types of hardware. Okay, so how do you use ece2? You type this command, and it's going to add the ece2 source code to your repository. So you can see it all. You can change it if you want. You don't have to change it, but if you felt like changing it, you can. We give you an example of how to use it. So if you go into the ece2 Quick Start Guide, it has this basic application program that basically is the best documentation that we have. Right? We have other documentation, but reading this program, seeing how it works, is probably the fastest way to see how do I use this graphics library, because you can see what is it doing, how does it do it. In any file where you want to make graphics calls, you include these two header files. ece2 application.hpp is basically about getting the window set up and creating things like buttons, and graphics.hpp is about being able to visualize, draw lines, So what does it do? It needs to take this, what's called an event, and somehow get it back to your program. Okay, so that your program can respond to it. Because the graphics library doesn't know what to do. But the graphics library is the one that knows about the event. Your program won't know about the event until the graphics API tells it. Okay, so the way this is done in